Today in 8th grade, we're going to be looking at arcs and special angles. Now they all deal with a circle. So we're going to be taking a look at circles again today. Yesterday we went over circumference and area of circles. Today we're going to be looking at just some of the different arcs and angles that occur inside a circle. Now an arc is part of the circumference of a circle, so it lies on the outside part of a circle. You can have two major types of arcs. You can have a major arc, which would be greater than 180 degrees, or you can have minor arcs, which are less than 180 degrees. Okay, so let's take a look at it as an example of each one. We have arc ACB, ACB, which is a major arc because it is greater than 180 degrees. A minor arc would be arc AB. Now you notice that in a major arc we use three letters to name it. It could have just as well been ADB or AEB. It just tells us that we're going along the outside. That should be a major arc, rather than if I just had the two letters, it would be then a minor arc. So we can look at arc AB is about a third of the circle, so arc AB is a third of 360, and we can say that it is 120 degrees. So if you look at a minor arc, and it's going to be the same degree measure as its central angle, and we'll get to that term in just a second. Okay, a semicircle. A semicircle is 180 degrees. In other words, it covers just half of a complete circle, and that's called a semicircle. So the measure of arc ACB, because we know a semicircle is 180, AB is 120, this leaves a measure of 60. So I have 180 plus 60 gives you a total of 240 degrees. So you can also find the measurement of major arcs. Okay, so the measure of arc ACB is 240 degrees. And we used what we knew about a semicircle being 180 degrees, and then what the other semicircle should be 180, and what this missing part is. Okay, a central angle is an angle with the vertex as the center. Okay, so your center point of your circle will be your vertex. So we can say angle APB is a central angle. And we're also going to learn that the measure of angle APB is going to be the same measurement as the arc AB. The angle that is described from a central angle and its arc are going to be congruent. Your arcs are also measured in degrees. So if we know this is 120, then we know the measure of arc AB is 120 degrees. A chord is a segment containing 2 points on the circle. Okay, so we have segment DE as a chord, segment CA is a chord, segment EA is a chord, segment CB is a chord, but PB is not a chord because it does not touch the edge of the circle. Okay, that's called something else. That's called the radius that we learned. All right, now let's talk about some more angles. We talked about an inscribed angle versus a central angle. The central angle is based on, and the key word here is central, or the center. That's where its vertex is. An inscribed angle is different because one of the vertex lies on the circle and the sides are just chords of the circle. So for instance, this angle right here is what we call an inscribed angle. Angle DEA is inscribed. Angle CAE is inscribed because my two sides are chords of the circle and the vertex lies on the circle. Now here's a note that you need to keep track of. An inscribed angle, unlike the central angle, to get its measurement, it's going to be half of the measurement of the arc. Half the measurement of the given arc. Okay, so if I know that angle ADE is 180 degrees, if this has a measure of 180 degrees and I were to draw an inscribed an inscribed angle, which means that both of the sides are chords and the vertex lies on the circle, then we would say that this angle would then be 90 degrees because it's half what the arc measurement would be. So inscribed angles, the measure of an inscribed angle is half the measure of its corresponding arc. Okay, so let's take a look at an example. Which one is the inscribed angle in this given situation? Okay, we can say angle YRZ is inscribed. Any others? Okay, angle ZYR would be an inscribed, and angle YZR. Okay, so all three of these are actually inscribed because they have its vertex on the circle. The only central angle we have would be angle ZSY, and it's actually a semicircle. Okay, so let's then talk about what happens in this case. Let's say the measure of angle YRZ. Okay, so here's YRZ is how many degrees? Okay, it looks like it's 90 degrees. What's then the measure of arc YZ going to be? Well, it will be double what the inscribed angle's measurement would be, since this angle is half what the measurement of that arc would be. So you're kind of working it backwards, and it would be 180 degrees. What's the measure of arc YR? Okay, so that's this one. Well, what do you need to know before you can find the measure of this arc? You need to know the measure of the inscribed angle. Okay, if this one's 50 degrees and that one's 90 degrees, what does this measurement have to be? Because it makes a triangle and they all add up to be 180 degrees, this would be 40 degrees. Okay, so if this inscribed angle has a measurement of 40 degrees, what is the arc that it creates? Okay, it'll be double that. It'll be 80 degrees. And the measure of arc is ZR. Okay, if its inscribed angle is 50, then the measurement of the arc will be twice that much, and we have 100 degrees. Now, we've covered all three sections of this circle, so those should total up to be 360, and I believe they do. Okay, do you have any questions about inscribed angles and the measurements of the arcs that they produce? Okay, now it's your turn. I want you in this example to list what the central angle is, what its measure is, and then I want you to list the arc from that central angle and what its measurement would be. And do the same for an inscribed angle. Name an inscribed angle, name its measurement, and then measure the arc of that inscribed angle. What would it be? Okay, when you get finished, I want you to compare with your partner, and then raise your hand and I'll come check you. All right, what is your first central angle? Okay, the central angle is angle ABC, or you could have it written as angle CBA. What is that measurement? That measurement would be 80 degrees. Okay, what is the measure then of that intersecting arc, which you call that the arc AC? What's the measurement of arc AC? Good, it would also be 80 degrees. They're the same. Central angles, their measurements are the same as their arcs that they intersect. Okay, can you give me an inscribed angle? Angle DEF is inscribed because its vertex lies on the circle. And what would the measure of that angle be? Okay, it's 20 degrees. Good. What will be the measure then of the corresponding arc, or the arc that goes with that intersects? Arc DF. What would be its measure? Good, it would be doubled, or 40 degrees. Okay, let's also go list another central angle, which would be your major angle. What would be the measure of angle AEC? If this one's 80, the whole thing's 360, what do you get? Okay, you get 280 degrees. Good. Okay, now let's try some examples on your own. Copy these down and let's find the measurements of the various arcs or angles as they are listed. All right, let's go over these. The measure of arc DB. Okay, so let's find DB. DB, it must be a minor arc because it doesn't have 3 letters listed, so we'll go around this direction. Okay, what do you notice about this arc? Okay, find its central angle. Its central angle is angle B. And what is the measure of that angle? Okay, 130 degrees because those two are vertical angles. Very good, using your previous knowledge. Therefore, the measure of that arc will be 130 degrees. Okay, so let's go down to D. We know that the measure of angle B is also 130 degrees. We can fill that one in. What about the measure of angle A? That's this one right here. Well, if this is 130, you notice they're supplementary because they make a 180 degrees. What will A be? It will be 50 degrees. Good. Okay, the measure of arc ECA. ECA. Okay, now what kind of an arc is this? It is a major arc. Okay, we know that the missing part, EA, is 130. Therefore, the rest must be the remaining. So how are you going to calculate that? All right, 360 minus 130 gives you 230 degrees. So this is a major arc, and the measurement is 230 degrees. We knew it had to be over 180 degrees. Another way you could have calculated if this was 180, due to this arc being a vertical, or this angle being a vertical angle has to be 50, you have 180 plus the 50 degrees would also give you 230. So that's just another way of looking at it. Okay, we already found the measure of angle B. What's the angle measurement of ECB? ECB. Let's do that. ECB. ECB. What is this measurement? What is the measurement of that angle? Now, how do I know that that's a right angle then in there? Are you sure? Okay, you can prove it because, look, it is an inscribed angle. It has its vertex on the circle. And its arc is a semicircle, which is 180, and its measurement must be half that, or 90 degrees. So that's how I know, not just because of the way it looks. What's the measure of arc BA? Okay, let's find BA. Okay, if we know the central angle is 50 degrees, then its arc is going to be 50 degrees. Good. Okay, what about the measure of arc DC? Okay, well here I know the inscribed angle is 20, therefore what does this arc measure? Good, 40 degrees. And the last one, the measure of arc CB. CB. How do I get that? CB. Okay, here's your inscribed angle. Okay, if we know that this is a right angle and this is 180, then these must be exactly the same, or 45 degrees. Therefore, the measure of that arc would be 90 degrees. Okay, today we worked on the parts of a circle, inscribed angles and central angles, the difference between those, and we tried to measure arcs, measurements, major and minor arcs. Are there any questions?